the number e as a limit, we have shown that if f of x is equal to the natural log of x, then f prime of x is equal to 1 over x. Thus, if we plug the value of 1 into that derivative, 1 divided by 1 is going to equal 1. So we now use this fact to express the number e as a limit. From the definition of a derivative as a limit, we have f prime of 1, which is going to equal the limit as h approaches 0 of f of 1 plus h minus f of 1 over h, which is equal to the limit as x approaches 0 of f of 1 plus x minus f of 1 over x. Now, as the limit as x approaches 0 now becomes the natural log of 1 plus x minus the natural log of 1 over x, which is equal to the limit as x approaches 0 of 1 over x times the natural log of 1 plus x. And if we write this 1 over x as an exponent of that logarithm, then the limit as x approaches 0 of the natural log of 1 plus x to the power of 1 over x. So because we know that f prime of 1 is equal to 1, then we would know the following. We would say that the limit as x approaches 0 of this logarithmic function is equal to 1. And you can see that on this graph. When we graph this function, this graph is going towards the value of 1. Now, by theorem 2.4.8 and the continuity of the exponential function, and we have the problem. E is equal to e, which has a power of 1. Well, what do we know that 1 equals? Well, 1 equals this entire limit. So this is e to the limit as x approaches 0 of that function. So we can say the limit as x approaches 0 of e to the natural log of 1 plus x to the 1 over x is equal to the limit as x approaches 0 of 1 plus x to the power of 1 over x. So for definition number 5, we see that e is equal to the limit as x approaches 0 of 1 plus x to the power of 1 over x. Now, formula 5 is illustrated by the graph of the function that we saw up here. Okay, and the table of values for small values of x, which we've done before. This illustrates the fact that, correct to 7 decimal places, Euler's number e is approximately 2.7182818. Now, if we put n and let that equal 1 over x, so substitute 1 over x to be n, then we can see in formula 5, then as n approaches infinity, as x approaches 0 from the right, and so as an alternative expression for e, then we have definition 6. E, which is equal to the limit as n approaches infinity, of 1 plus 1 over n to the nth power.